Imagine looking up at the night sky, seeing countless stars, nebulae, and entire galaxies. Now imagine a force so immense, so incomprehensibly powerful, that it's pulling our entire galaxy, the Milky Way, along with millions of others, through the universe at an astonishing speed of 2.2 million kilometers per hour. A gravitational anomaly so massive and so pervasive, it's essentially a cosmic vacuum cleaner, dragging everything within its reach towards an unknown, unseen destiny. What could possibly possess such incredible, almost terrifying power? To understand this profound mystery, we need to grasp a fundamental concept: the expansion of the universe. For decades, astronomers have observed that the cosmos is not static but constantly expanding, pushing galaxies further apart from each other. However, within this grand expansion, galaxies are also influenced by local gravitational forces. Our own Milky Way, for instance, is in a gravitational dance with its galactic neighbors, slowly but surely approaching the Andromeda Galaxy for an eventual spectacular collision billions of years from now. But this local attraction isn't the full picture. Scientists began to notice something far grander and more perplexing: a uniform, colossal drift of entire galactic superclusters, a movement that couldn't be explained by known gravitational interactions within our immediate cosmic neighborhood. It was as if something was tugging on the very fabric of space-time, orchestrating a cosmic ballet on an unimaginable scale. This inexplicable motion was first hinted at in the late 1970s and early 1980s. Astronomers like Vera Rubin were meticulously measuring the velocities of galaxies, and what they found was deeply unsettling. Our galaxy, the Milky Way, wasn't just drifting, it was being actively pulled in a specific direction, along with thousands of other galaxies in our local group and beyond. This wasn't just a gentle cosmic breeze, it was a powerful directional current in the ocean of space. The initial hypothesis was startling. There had to be an enormous concentration of mass, a gargantuan gravitational well, lying somewhere in that direction, exerting an irresistible pull. They named this hypothetical unseen entity the Great Attractor. But here's where the mystery deepened. The direction our galaxy and many others seemed to be heading was towards a region of space that was notoriously difficult to observe. It lay directly behind what astronomers call the Zone of Avoidance. This is a band across the night sky, right along the plane of our Milky Way galaxy, where the dense gas, dust, and stars of our own galaxy obscure our view of what lies beyond. It's like trying to see across a crowded, brightly lit stadium from a perpetually foggy window. The sheer amount of galactic material makes it incredibly challenging to penetrate with optical telescopes. It was a cosmic blind spot, and right in the heart of it, scientists suspected, lay the source of this immense gravitational pull. Was the universe playing a cruel joke, hiding its biggest secret behind a veil of cosmic dust? For years, the Great Attractor remained largely theoretical, a gravitational ghost haunting the scientific community. How do you study something you can't see? Scientists had to get creative. They started employing different wavelengths of light, like infrared and radio waves, which could pierce through the obscuring dust more effectively than visible light. Slowly, painstakingly, they began to map out the region behind the Zone of Avoidance. What they started to uncover was not a single giant object, but a sprawling, complex structure. It appeared to be a supercluster of galaxies, an enormous collection of clusters, each containing hundreds or thousands of galaxies, bound together by gravity. This colossal structure was later identified as part of the Norma cluster, and even larger still, the larger Laniakea supercluster. But even with the discovery of these titanic structures, the numbers didn't quite add up. The observed mass of the galaxies and visible matter within these clusters wasn't enough to explain the immense gravitational pull. This led to a crucial, even more bewildering conclusion: a significant portion of the Great Attractor's influence must come from something invisible, something we cannot directly detect. Enter dark matter, the enigmatic substance that astronomers believe constitutes about 27% of the universe's mass but doesn't interact with light. making it utterly invisible to our telescopes. The Great Attractor, it seemed, was not just a collection of galaxies, but likely an immense concentration of dark matter, drawing everything towards its unseen core. Then in 2014, a groundbreaking study using an innovative technique called Cosmic Flows 2 provided a more detailed three-dimensional map of galactic movements across a vast expanse of the universe. This study didn't just confirm the existence of the Great Attractor, it revealed an even more complex cosmic dance. It suggested that our local Supercluster, a sprawling collection of over 100,000 galaxies dubbed Laniakea, meaning immense heaven in Hawaiian, was not only being pulled by the Great Attractor, but was also being pushed by a vast empty region of space, a cosmic void, aptly named the Dipole Repeller. This was a breakthrough. It wasn't just one colossal entity pulling everything, it was a push-and-pull dynamic, an intricate gravitational ballet orchestrated by both massive concentrations of matter and vast regions almost devoid of it. The universe wasn't just expanding, it was flowing, like a river with currents, eddies, and whirlpools, all guided by unseen forces. What they discovered next was a confirmation and an expansion of the mystery. The flow of galaxies wasn't just towards the Great Attractor, it was a much larger, more coherent movement, where Laniakea itself was just one component. The Great Attractor, while significant, might simply be one of the densest knots in an even larger cosmic web of dark matter and galaxies. The velocity of our Milky Way and its neighbors, that astonishing 2.2 million kilometers per hour, isn't just about escaping an expanding universe. It's about being dragged by an irresistible force that we are only just beginning to comprehend. The force driving this movement is so powerful that it's challenging the very models we have for the distribution of matter in the universe. Is there something even bigger lurking beyond the Great Attractor, orchestrating its movement too? To this day, the Great Attractor remains largely an enigma. While we've made immense progress in understanding its general location and the larger structures it's embedded within, the precise nature of what constitutes its core remains a subject of intense research and speculation. Is it a single supermassive concentration of dark matter? Is it simply the gravitational focal point of a truly immense, unseen supercluster of galaxies and dark matter that extends far beyond what we currently observe? We are, quite literally, being pulled through space towards something we can't fully see, a gravitational monster hidden behind a veil of cosmic dust, and perhaps even more profoundly by the limitations of our current understanding of the universe. If you want to explore more cosmic mysteries like this, the next video dives into the perplexing evidence for Planet 9, another unseen gravitational force shaping our solar system. The universe, it seems, is full of unseen architects, subtly pulling the strings of cosmic destiny.